factors of perfect square trinomials or PST. So before we apply the method of factoring of PST, so first we need to determine if the given trinomial is a perfect square trinomial or not, because we cannot apply this method if the given is not a perfect square trinomial. So let's have some examples here. So let's say we have 16 times e raised to 4 minus 24 times e raised to 2 plus 9. Okay, so first let's determine if the following is a perfect square trinomial or not. Okay, so this is the questions that we need to answer to determine if the following trinomial is a perfect square or not. Okay, so first is the first term a perfect square? So is 16e raised to 4 a perfect square? The answer is yes. Okay, so if we get the principal square root of 16e squared, so that will be 4. The square root of 16 is 4. And the square root of e raised to 4 is e squared. Okay? Next, is the last term a perfect square? So our last term here is 9. And the answer is yes. So 9 is a perfect square. So if we get the principal square root of 9, that is equal to 3. So 3 times 3, that is equal to 9. So for the middle term, is the middle term must be twice the product of first and last terms. And when we say twice, we need to multiply it by 2. Like this one here. So this is for the first term, the square root of first term, and the square root of last term. And then we need to multiply it by 2. Okay, so let's do so. So we have 2 times 4, that is equal to 8. And 8 times 3, that is equal to 24. And then our variable here, which is e squared. Okay, so as we can see, the numerical coefficient and the variable of the middle term is equal to our product here. So again, we need to twice the product of the first term and the last term here. So the answer must be equal to our middle term here. So that means 16e raised to 4 minus 24e squared plus square root of 9 is a perfect square trinomial. Okay, so now that we know that this given trinomial is a perfect square trinomial, let's apply the method of factoring it. So how to factor it? So first, we need to get the square roots of the first and last term. The square root of first and the last term. Okay? So, again, the square root of 16e raised to 4, that is equal to 4e squared. Okay? Next is the square root of 9, that is equal to 3. And then for the sign or the operation in between them, so all you have to do is to use the sign of the middle term of the trinomial between these roots. So as we can see here, the sign or the operation used by our middle term here is subtraction. So that means our answer here must use subtraction also. And then raise the binomial that we obtain to the second power. And that's it. So again, first step, get the square root for the first and last term. So 16e raised to 4, that is equal to 4e raised to 2, and then the square root of 9 is 3, and then use the sign of the middle term, this one, and then raise the binomial into square. And this is the factor for this perfect square trinomial here. Let's have another example. So we have a squared plus 2a plus 1. Okay, so again, first step. So let's get the square root of the first and last term. So a squared, so the square root of that is equal to a. Okay, so if the exponent is squared and we need to get the square root, we just cancel it. Okay, a squared, and then the square root of 1, that is also equal to 1. 1 times 1, that is equal to 1. And then we need to use the sign or the operation of our middle term here, which is addition, and then raise the binomial into square. And that's it. This is the answer. Okay, so for our third example here, the last term and the first term are both variable, but all we have to do is to follow the same procedure. So first, let's get the square root of the first and last term, and then b squared, the square root of b squared is, we just cancel it, so that is b, and then the square root of c, let's just cancel it since the exponent is 2, and what is left is c. And then let's use the operation or the sign of the middle term, which is minus, and then raise the binomial into square. And that's it. This is the factor of the perfect square trinomial.